Let's open up the programmer's toolbox and get a handle on some of Python's most powerful tools for automation. Loops.
You ever wonder about that? You type a name and bam, there it is. How does your phone search through maybe 1,000 contacts in the blink of an eye? Well, it's definitely not magic. It's automation. And the secret sauce is exactly what we're about to unpack.
Okay, so let's dive right in by looking at the basic problem that these tools were even created to solve in the first place.
I mean, can you even picture it? Trying to type the same line of code 1,000 times? It would be incredibly slow. You'd make a ton of mistakes. And for tasks that have millions of items, it's literally impossible. This is exactly why loops were invented.
So, the first tool we're going to pull out of the toolbox is the for loop. This is your absolute go-to when you know exactly how many times you need to repeat something. You know, like going through every file in a folder or every single student on a classroom roster. The best way to think about it is like a factory assembly line. You've got this conveyor belt with a bunch of items on it. That's your sequence. The loop just picks up each item, does its job, puts it down, and moves right on to the next one until the belt is empty. And the syntax for this is just beautifully simple. We use the range function to create our little sequence of items. Then the for loop takes each of those items one by one and assigns it to a variable. Here, we're just calling it I. Then it does something with it, like printing it to the screen. So on the very first pass, what we call an iteration, I gets set to the first value in our range, which is 1. And then the code inside the loop, print I, gets to work. After that's done, the loop just automatically moves on to the next value. So now I is 2, and that print statement runs all over again.
And finally, I becomes 3. The code runs one last time, and since there's nothing left in our sequence, the loop just ends. Its job is done. Simple, clean, and super efficient.
Now, here's one super crucial detail about that range function you have to remember. The stop value, think of it like a wall the loop runs up to but never actually touches. It is never included. So if you write range 111, you're going to get the numbers 1 all the way up to 10, but you won't get 11. That's a key point that trips up a lot of people.
So that's our first big tool. But what if you have no idea how many times you need to repeat something? Well, for that, we need to pull out a different tool, the while loop.
You see, this loop isn't like an assembly line. It's more like a watchful sentry, a security guard. It stands there and constantly checks if a certain condition is true, and it will keep executing the code over and over as long as that condition stays true. This is perfect for things like video games. The main game loop runs while the player's health is above 0. The second that condition becomes false, the loop stops. And this table just lays out the core difference perfectly, doesn't it? You use a for loop when you have a definite number of things to go through, a list, a range, whatever. You use a while loop when you're just waiting for something to change, like waiting for a user to type quit.
Okay, so we've got our heavy-duty tools, the for and while loops. Now let's look at the precision instruments, the tools that give you even more control to fine-tune exactly how your loops behave.
These analogies really make it clear. Break is like hitting the big red emergency stop button. It gets you out of the loop completely, right then and there. Continue is more like telling one person on the assembly line, "Nope, not you," and just skipping to the next one. And pass, well, that's just a placeholder telling the program, "Yeah, I see this, but just do nothing and move on."
So to really see this in action, let's set up a quick baseline. Here is the normal, boring output of a simple loop just printing the numbers 1 to 7. Nothing surprising here, right?
Okay, now watch what happens. We add one little condition that tells the loop to break if I is equal to 5, and boom, the whole thing just stops dead. It never even gets a chance to print 5 or 6 or 7. It's just over.
But check out the difference with continue. When I gets to 5, the loop just says skip and jumps right to the next iteration. It doesn't print 5, but then it just carries on with 6 and 7 like nothing ever happened. Now that is surgical control.
All right, you've seen the tools in the toolbox. It's time to put them all together and see if we can solve one final practical challenge.
So here are the rules of the game. We've got to loop through numbers 1 to 20. We need to use a continue to skip all the even numbers. And then we need a break to shut the whole thing down the moment we hit number 17.
And here it is, the elegant solution. Now, notice the order here. It's really important. First, the loop checks for the game over condition, our hard stop at 17. Then it checks if it should skip the number with continue. Only if the number passes both of those tests does it finally get printed. This is a perfect example of how you can master a program's flow.
You see, getting good at loops and control statements isn't just theory. It's the real foundation for building anything powerful, dynamic, and efficient. Whether you're sorting massive amounts of data or building the next great video game, this is where that automation truly begins.